Hello again, our most valued student. My name is Confident. Welcome to our continuation on the topic of electricity, and in this section I'm looking at a series and parallel circuit. So what do we mean when we're talking about a series and parallel circuit? This is actually determined by the resistors in the circuit. For example, if we're talking about a series, as we looked at previously, we said these types of resistors like this, they are in series. The reason being, if you follow the flow of current, you will see that the same current that passes through R1 here is the same current that passes through R2. So these resistors are in series. And then when we looked at parallel circuits, we say if we have a resistor like that and we have our supply, such resistors, we said they are in parallel being. If you look at the flow of current, if this is the positive negative, at this point or the junction, the current is going to split. Some of it will go to resistor R2, so this will be current I2, and some of it will go through resistor R1, and we can call it current I1. So you can see that these two resistors are having different types of current. If resistor 1 has got a different current from resistor 2, we are saying these resistors, they are in parallel. And then if the current that passes through I2 and the current that passes through R1 is I1, if I1, which means current 1, is equal to current 2, we are saying these resistors, they share this, they have the same current. They are not sharing, but they are having the same current. We say they are in series. So remember that. Now when we are looking at this scenario where we say it's a series and parallel circuit, we are saying you can find resistors like this, which are in series and connected to in the same way. If you can look at this diagram to say at this stage, if you can have something like that, we are saying if you look at the flow of current here, you can see that R1 is in series with R2. Reason being is the same current that is passing through. If it's I1 and here it's I2, we are saying I1 is equal to I2. This is similar to the diagram. But now if you come at this juncture, what is going to happen is some of the current will go through resistor R3 and some of the current will go through resistor R4. So we'll call this I3, meaning current 3 will come through, will flow through R3, as well as current I4 will flow through resistor 4. So when the current splits like that, we are saying these resistors here, they are in parallel, while the resistors here, they are in series. So we are saying this kind of combination here is called a series parallel circuit. So that's what it means. Now when we are looking at the next part to say how do we actually analyze these circuits, because if you fail to analyze them, they will actually lead you to make some wrong calculations. So how do you analyze them? There are a few concepts I want to bring to you. Just as I've laid a foundation, there are some misconceptions that sometimes students are tempted to conclude. For example, if I draw this kind of a circuit to say I have my resistors in this format and I have my supply here. Now if you look at this kind of a connection, the question is, are these series or parallel resistors, or is this a series or a parallel circuit? Now what it looks like a parallel circuit, if you just observe like that, you'll think they are in parallel. But remember, always follow the flow of current. So if this is my flow of current, the current that it will go through resistor 1, we'll say it's current I1. So it is the same current that is flowing out of resistor 1. Now the same current that is entering R2, as you can see, is the same current. This R2 is the same current that came from I1. So you can see that I2 is the same as I1. So you can see that the same current is flowing through the same resistors. So these resistors, in fact, they are in series. So don't look at the picture and conclude that they look like they're in parallel. It means that they're in parallel. In as much as they look like they're in parallel, remember these are in series, because the same flow of current that goes through R1 is the same current that is going through R2. So remember such misconceptions. Now, how will it look like if it was a parallel combination? It will have looked like this. If I can draw a similar circuit to say, if I wanted to make this a parallel combination, so I was going to have my supply instead connected like that. So you see now, when I've got my supply connected in this fashion, what I have is this is the flow of current. Every time you come to a point where the current has to separate or split, then at that point the resistors that are following, they're in parallel. For example, if this is my R2 and this is my R1, we are saying current, some of it will become current I2, some of it will become current I1. So the fact that there is a splitting or a separation of current, it means the resistors that follow, they are also in parallel. So just remember this kind of misconceptions, because it always kind of tricks the students. Another scenario that you can find when it comes to parallel and series connections, you can have, for example, a situation or a connection that is like this. If I can maybe have it like that. So look at this connection here. If you have a connection like that and I have my supply like this, so if you look at this kind of a scenario, we are saying the flow of current, if the current is flowing in this direction, when it comes to that junction here, the current is going to split. So let's say I've got my R1, my R2 and my R3. So the current that is going to flow into this resistor R3, we will call it current I3. And then in here, the current that will flow through R1, let's call it I1. And the current that will flow through R2, let's call it I2. So look at the current here. So you can see that there was a splitting of current in these two resistors, because part of it became I3 and part of it became I1. So it means these two resistors, they are in parallel. The reason being, they have a different current flowing through them. Now, something is interesting though in this scenario, because you can see that I1 is equal to I2. Why? Because the same current that is passing through R1 is the same current that is going to pass through R2. So you can see that we have a scenario here whereby some of the resistors in the circuit, they are in series, and some of the resistors in the circuit, they are in parallel. So we call this a series parallel combination. So what do? You have to deal with this series component first. We're going to look at examples in the following chapters. So after dealing with this series combination, then you are going to look at this parallel combination altogether. So these are the techniques that are very important for you to understand. I can also come with another scenario here to say, if I draw a circuit like that, as you can see that, so this is my circuit. Now in this circuit, if I have my power supply like that, now the question is, if I'm to analyze these resistors and I have got my R1, my R2 and my R3, and if this is my flow of current from positive to negative, now looking at that particular junction here, you can see that the current is going to split, with some of it going through resistor 3, we call it R3. Some of it will go through R1, I'm going to call it current I1. But now look at this, the same current that comes out of I1 is the same current that is entering R2, I'm going to call it I2. So you can see that in here, I1 is equal to I2. So which means these two resistors are in series. The reason being they have the same current passing through them, but they are in parallel with resistor I3 to say R1 and R2 are in parallel, it's like that, with resistor R3. So this is kind of a scenario that you'll be having in actual fact, whereby R1 and R2, they are in series and you have to deal with them as a series combination, while the two resistors, after you've combined them, they are in parallel with R3. So as I said, it is very, very important for you to be able to analyze these resistors. If they look parallel, it does not mean that they are parallel. You need to look at the flow of current. When the current does not divide and the same current is passing through all the resistors that follow, it means those resistors are in series. So if I can have a scenario to say I've got a resistor, I've got a resistor, I've got a resistor, and I've got a resistor, and I've got a resistor, and I've got a resistor. It doesn't matter how many resistors I come up with. And then if I come and have my power supply in that fashion to say I've got my resistors like that, and I've got now my power supply like that. What is important is always to follow the flow of current. When current comes here, it is going to separate. As you can see, when it comes here again, it further splits. Whenever it's separating, it means, okay, these two resistors, as you can see, it means they are in parallel. Why? Because you will have current, let's say this is R1 and this is R2. You will have I1 and I2 being separate, but look at I2. This is the same current that goes through resistor I3 and the same current that goes through resistor R4. So this current, it means these resistors are in series. And then when you follow up, you can see that there was a combination of this I1 and this I3. So it means this combination is in parallel, meaning you had to add first the series so that you come up with a parallel combination. You are left with a parallel combination, and then from there you can see the same current that passes through R5 is the same current that passes through R6. So the combination here is in series. So it's a matter of, as I said, understanding how to analyze your circuits. We're going to look at more of these in the coming chapters. I brought in here a typical exam so that you can be able to have enough practice. So I'll encourage you to go through the previous lesson where I did a similar question, but this one also comes with a different twist. So let us look at this question here. It says you are given two resistors, and then these two resistors is the 20 ohm and the 30 ohm are connected in parallel. This parallel combination is connected in series with a third resistor of 25 ohms. So the connection there is a series. The whole circuit is then connected across a 50 volt supply. So now this is the information you're given. So you need to have kind of a sketch before you can do any calculations how it look like. So first things first is they told us here we've got two resistors, 30, 20 and the 30 that are connected in parallel. So if I'm to have that, I'm going to have a scenario like that to say there is one resistor there. Let me make it a bit longer. So we have this resistor which is connected in parallel like that. So this is a parallel combination. I will explain why is this a parallel combination. Okay, so now that's what we are having. I'm just struggling to draw a straight line, but it's fine. And then they are saying here these are connected in series with a third resistor of 25 ohms. So you need now to come with a series scenario like this. Do you see that? And from there, they are telling you that this whole thing is connected across a 50 volt supply. So that's what you need then to combine this to a 50 volt supply. So this is our 50 volt. So what I was trying to do there when I was saying, I'll explain that, to say if this is our R1, in this case, because I need to write the number, our resistor 1 and our resistor 2, they told us our resistor 1 and resistor 2, the values are 20, 30, and the other one is 25. So we have got here 20 ohms, and then we have got 30 ohms, and then so this is that, and here we've got the R3, let's call that R3, as well as the, and call it 25 ohms. It's up to you how you label them, but you need to be consistent in terms of knowing which R are you using. So it doesn't matter, you can call the R3 R1, it's up to you. So let me call this my positive and my negative. So when current flows from the supply, we call it the total current because it's coming from the supply. It will go through here, still being the total current, but when it comes through that junction, it is going to split with some current going inside resistor R2. Let me call that I2. Some of it will go inside resistor R1. Let me call it I1. Now, after they come out of R1 is I1 and they come out of R2 is I2, they are going to combine again here, meaning I1 plus I2 will give us back our total current, which is IT. But because it's entering through resistor 3, we can also refer it as I3. So you can see that I3 here is equal to IT. It's the same thing. So the current will come out as total current, and this is the total current. So this is a scenario that you use to analyze, but it will help you answer the questions. Let us look at the first question. It says, first part is, we need to calculate the following: the total resistance of the circuit. Now 3 marks, as I say, to find the total resistance here, which is your RT of the circuit, the whole circuit. We need to find the total resistance of the circuit. You cannot do that until you can solve the parallel combination first. That's the first part you need to remember. Do not forget, you need to solve the parallel combination, and the formula is 1 over Rp for parallel combination is 1 over R1 plus 1 over R2. So these are our two resistors here, R1 and R2. And then if I can write here to say 1 over Rp is 1 over the R1 in this case, which is 20, plus the R2, which is 1 over, in this case, 30. So you see what we're having? It's up to you now. Remember, I told you to be careful how you go about this. You are still getting 1 over Rp, so that's why you say 1 over 20 plus 1 over 30. So it will give you, this case, 1 over 12, which, as I said, it's up, you can take this to the top and that to the bottom. It will give you your Rp here is equal to, and then again similarly take the 12 to the top and the 1 to the bottom. It will give us 12 over 1, which is simple 12 ohms. So that is the parallel combination, the total resistance of this parallel combination. That's what I was finding here. So we have the total of that parallel combination. So now once we have it, this is not done. They say the total resistance. You can now see that the diagram is more like this, whereby here we have our Rp being now 12 ohms. Are you seeing that? And then we still have our series connection of 25 ohms. Don't forget that one here, which was our R3 equal to 25 ohms. So you still have that, and still connected to our supply, which is the 50 volt supply. So when you again follow the flow of current, this being your plus or minus, is you can see is IT here that is entering through the RP is the same IT which is entering through R3, which you say it is, you can label it IT or R3, it's up to you, and it's IT. So since it's the same current flowing, these two are now in series. Are you seeing that? So now, how do you solve these two resistors in series? You simply add them to say now our RS, which is R series, is equal to RP plus R3. But our RS, which is our R total, you can actually use T instead to say the total resistance, RT, is equal to 12 plus 25. And then when you add that 12 plus 25, it is 37 ohms. So that is our total resistance. And that, just to verify, if it's 12 plus 25, it gives me 37. So that is what I'm having as the total resistance of the circuit. So that is what they need when they wanted me to find the total resistance for 3 marks. The next one is the current drawn from the supply. The current drawn from the supply. So which means when they are talking about the supply is the 50 volt. Now the current drawn from this 50 volt, you are using the same formula from, as I said, remember, part of your Ohm's law. When they're talking about current, voltage and resistance, always remember your Ohm's law, which is your V, your I and your R. So the current drawn from the supply, meaning your IT, is equal to V, in other words the total voltage, over the R, which is the total resistance. So your IT here is equal to total voltage, they say it was 50, and then the total resistance that we got 37 ohms as RT. Remember, that's what we're using. So it will be over 37. It will then give us the answer there to say what is the total current we are having. So 50 divided by 37, it gives me 1,351 to 3 decimal places. So it's 1,351. Current is measured in amps. So this is the total current that you expect here to say 1,351. It is the same current that is coming from here as 1,351. That is the total current that was flowing. But this same current split here as I2 and I1, and then so that is what you need to know, how much went into R1 and how much went into R2. The next one says the volt drop across the parallel branch. So now when they are talking about the parallel branch, let's look at this branch that they're talking about here. This is my parallel branch. Now if I'm looking at the volt drop, one thing I want to remind you is, if I want to find the voltage here, and also I want to find the voltage here, remember this is a parallel combination. So if this is V1 and this is V2, you must know that the voltage, because of the parallel combination, V1 is equal to V2. Voltage in a parallel resistors is maintained the same. So when you look at a parallel combination, the voltage is the same across that. So V1 is equal to V2, meaning if you find the voltage across R1, you have found the voltage across R2, like that. But we have got a simpler scenario here whereby I can come to this diagram and find that VP there. You must go to the combined resistor and try to see if you can use it to find VP. In this case, it is possible if I use here the formula. Remember, as I said, it's always important for you to remember the Ohm's law. So if I use the Ohm's law here, being V, I and R. So if here I use the Ohm's law to say V is equal to IR, or I times R, but here remember it's V parallel, and then it's I, that is the total current. You can see IT, that is entering, and then times R, which is R parallel. Are you seeing that? So if I can find the VP there, meaning the voltage across the parallel combination, from what the question was saying, says the voltage drop across the parallel branch. As you can see that they use the word parallel there. That's why I'm focusing it. What was the total of that parallel branch? So it is I, which we found I to be 1,351, the IT. So it's 1,351 times the RP. Now the total RP we got as 12 volts. So you must use only the RP there for 12. So VP in this case is equal to, if I use then my calculator there, it will be 1,351 times 12, and it gives me 16,212. So it's 16,212. Now I'm looking at voltage. The answer is going to be in volts. So that is the answer that you get there. The next one says the current flow through each of the parallel resistors. Now you see, I'm given the RP, but it takes me back again to find I1, which is the current through each of the resistors, and I2. But now the good part about this is I already know what the voltage was. The voltage V1 and V2, we said they are the same. So now what is my V1 and what is my V2? My V1 and V2 are going to be 16,212. So I write here as 16,212, and also here 16,212. So you see that since I know the voltage and I know the resistance, the question now says I need to find the current flowing through. Remember the formula? I used this formula here to say I is V over R. So if I use that formula in each one here, for this particular scenario, I1 is equal to V1 over R1, which is equal to I1 is equal to V1 is the same, 16,212 over R1 is 20, then to give us the answer. And then again, I2 is a V2 over R2 in this case, which is equal to my V2 is still the same, 16,212 over, in this case, R2 is 30 ohms. It will also give us the answer for I2. So let us look at these answers here to say 16,212 divided by 20. It gives me 0,8106, which is 0,811. So it's 0,811 amps. That's the answer there. And then for the other one, I'm getting 16,212, and then I'm dividing by 30 in this case, which is equal to 0,5404, which is 0,540. So this is also in amps. So you see, I1 and I2 I know. Remember, when I add I1 and I2 for interest sake, I must get my total current, which is 1,351. Remember, my total current is that. Let's add that and see if ever it is giving me the total current, because we must get back to the total current. If I say 0,811 plus 0,54, we must get to the original current, which is 1,351. You see, it takes me back to that current there. And then lastly, I think, okay, we still have, yes, that is the question now. We found the two resistors, the current that was flowing through the two resistors, which was in this scenario, that part. Now the last one, it says the current flow through the 25 ohm resistor. So they want now this current flow through this resistor. Now remember, simple one. I3 is equal to IT, and we know our IT here. Our IT is 1,351, so we don't need to calculate even here to say. When we know IT, which is 1,351, it means also I3 here is also going to be equal to 1,351, because they is the same current, just that it is labeled differently. So I know it took a bit of long time working on this one, but I wanted you to analyze this properly and be in a position to be able to follow and flow through all these calculations without a problem. I hope you've come to the end of our lesson. Join me again in the next sections where I continue looking at some of these techniques for you to answer parallel and combination circuits. We've come to the end of our lesson. Thank you.